Okay, maybe that's better. Make sure my laptop is plugged in. I think my last stream was the Zelda stream or something. Or no, maybe I programmed after that. But man, a lot of internet fanboys got mad that I don't like Legend of Zelda. Let me tell you. It's a little bit psychologically concerning. Yeah, the iOS app for Twitch is amazingly bad. Like, I don't even know why they keep it up on the store in the state that it's in. Oh yeah, I did Witcher 3, that's right. I did that after Zelda. Oh, Zelda had plenty of lemons. Witcher 3 had fewer lemons, but that's good. Having fewer lemons is good. And I think they're not quite lemons if they happen over time, the way the Witcher lemons do. And if combat doesn't pause when you go to the inventory, which it doesn't, I don't think. What's the progress on the polymorphism cleanup? I finished it. Basically, the whole cleanup is archived. So I finished it last when I was in Seattle, a week ago or whenever that was, week and a half ago. So that's good. It's the polymorphism system is in good shape now and ready to be built on. So I'm curious if you can pass in an entire SOA row of elements into a function as an array, or do you have to pass in elements individually? No, the whole point of SOA is that they're in an array. So yes, you can do that. However, I am deprecating the SOA functionality in the language right now in favor of something that's going to happen later that's going to be better and a more inclusive feature. So we'll see how that goes. The lemons thing is from when I was playing Prey, and I had to eat lemons all the time. There were just a bunch of lemons. Was it big work to get those perf increases or just going through cleaning stuff up? It wasn't big work. But you have to be not scared to change some core things in the compiler. But you know, that was about a day or a day and a half of work to get it going as fast as it is now. I should remind myself. Whoops. Big reminder to myself. Start in about. This is a lie, because I always give people a little extra time to show up. How do I get baited so hard by apologists? Isn't the problem developers rationalizing forced choices rather than making bad choices? Yes. The thing is that I feel, given how bad software is now and how negatively that impacts everybody's lives, I feel a moral obligation to try to make the case that some of these things that people seem to believe are woefully incorrect. Now, Twitter is not the best venue to make that kind of a case because the amount of reach that you have versus how much effort it is to reply to all the replies is not very good. And it's very difficult to make a flow of reason that people can follow, right? So, you know, but it's just, if I'm stuck somewhere in my car in stop traffic and people are trying to claim to me that JIT is a good idea, then I will respond to them. I'm going to tweet that I'm starting in a couple of minutes. Do I have an idea of how much work it will take to get rid of the linker? I don't necessarily think it's going to be that much work. There's like two main things that need to happen, maybe three main things. What is that noise? Something in the water pipes. One of the things that needs to happen is to actually write an executable file instead of an obj file, which are both variants of the same file format, so I don't expect that'll be too hard. The second thing that'll happen is, I have to, instead of relying on the linker to link static libraries, I either have to duplicate that functionality of linking static libraries or provide a different way to link the libraries. And I think that initially I'm going to load them as DLLs at startup instead, because that's faster anyway for some reason, and that doesn't make any sense that that's faster, but it's true. It's tremendously faster. So I'm going to do that. And then the third thing is, I'm not sure to what degree I have to make sure that I generate position-independent code for all the branches in the code that we output, because I'm not sure to what degree the linker needs to fill those in versus maybe I can just fill them in. Like maybe part of doing the executable format involves filling those in anyway. So I need to look at that. But it's not, I don't anticipate it being a tremendous amount of work. It's just a lower priority. All right, I'm going to go tweet now. Compiler demo is imminent. And the URL. Twitter always has a cached thing. Okay, hold on. Why do I even bother talking to these people on Twitters? All right, so that's announced. I replied to another lame person on Twitter. I'm just not going to reply to this other guy. I don't understand how so many people can be like mediocre programmers because of the ideas that they're so willing to defend. It's like, just stop defending that idea and you'll be better. It's crazy, crazy. Okay. What is threading going to be like? Threading is already there. It's going to be like native threading from your operating system. Would it be possible to move the mic away from the keyboard? Unfortunately not, because, I mean, the keyboard I'm using now is not the one I'll be using during the demo. But I'm using this webcam that's just on top of the monitor, and the mic is part of the webcam. In Seattle at home, I have a setup with a separate mic that I can move around, but this one is not a separate mic. Yeah, I'm going to do a stream on something related to meditation soon. Let me change this to about, we'll give people 5 minutes to get here. Have I commented on the job system used by the compiler? A little bit, somewhere, but it's not a very, it's like the most minimal job system you could imagine. It's not really doing anything that interesting. Do I know any big names that are excited for this language? I know some people in the industry that are very interested in it, but it's not good to name names. And also, the more higher profile person that you can name, the more they're kind of busy doing their stuff and aren't paying attention to this kind of thing. So the more, the really busy people tend to pay attention to something when it's proven out, right? And this isn't proven out yet because I'm not even releasing it to anybody until it's further along. So, yeah. Oh, it's Abner. Hi, Abner. Is there a name for what will become the superset of SOA? Not yet. Not yet. I need to figure it out. Will the linker ever go away? Yes, probably. Do I think programming today is less about computer science and more about building quickly or scalable, or insert buzzword here? When I started programming, it wasn't about computer science either. I didn't know computer science until I'd been programming for like 7 years. There's just something bad, there's just something rotten going on in programmers today. And I don't, it's like they want to not put in the work to be good, but they want to believe that they're good, right? It's this two-sided, weird thing. They want to believe that they're right and that they know everything and that their chosen methodology is the best, but they won't look at any evidence about whether it's the best, and they won't push themselves to explore other things and see if those things are better. So it's, I mean, I guess that's relatively typical human psychology, but it's just ugly that it's happening now at such a scale, and that the fact that the scale at which it's happening is impacting so many people's lives negatively. Did I go about architecting the witness editor? Architecting is a strong word. It sort of grew organically over time. The witness editor is not a separate program. It's built into the game. So you're in the game and you hit F11 and you're in the editor and then you go back. So it's not, there wasn't a thing about separating into a separate program. It's not a separate program. Oh, Abner's live NASA lecture is close to completion. Really hopes that explaining how we have to motivate them to apply some of that philosophy. Yeah, I mean, I'm going to be really interested to hear that because I've heard vague things about how that stuff goes, but I'd be interested to hear it firsthand. And I think, you know, it's impractical. Like for a game programmer, I think it is impractical to adopt any of the software engineering methods used by various parts of NASA because it's just way too expensive, right? Like for the amount of functionality we need to build, and it takes too long. But if some of it can rub off, if like the right parts can be employed in the right contexts, I think it could be very helpful. Yeah. All right. Do I see any drawbacks of having the editor inside the game? Well, one of the programmers, I sort of had a mild argument with someone at one point where he said that, because the editor is in the game engine, it sort of limits how much you can optimize the game engine renderer, because when you optimize things, you want it to be all processed and crammed together. And the editor, you need to do things piece by piece. But I don't think that's true. Like, I think that you can always just make a new entity for the super processed stuff and be able to render both things, the slow path and the fast path. So, I mean, there might be a degree to which it impacts you, but I think it's small. I don't think it's large. But, that I don't know if we ever resolved that with one person believing the other person was right about that. So who knows? All right, I'm going to take a 1 minute voice break, 2 minute voice break, and then we'll start. Get some water. Hello, everybody, and welcome to yet another demo. This demo is not going to be about amazing language features that no other language has. It's going to be about filling in a few gaps that this language previously had not filled in, right? And so the gap we're going to talk about today is constructors and destructors. And the design of constructors and destructors in this language is very different from most languages. It's especially very different from C++. And I wasn't sure for a long time that I was even going to have constructors or destructors. And I should say, before I say anything else, that I'm not completely sure that everything that I'm going to show today is actually a good idea. It might get ripped out of the language later. But I have what I think is a justification for it that seems to make sense. And so, like, at the current time, it seems to make sense to go in this direction. and do a version of constructors and destructors that provides what I believe is a useful functionality of those kinds of routines without getting into the horrible, miserable rat holes that C++ gets into. All right, so let me talk about why we're doing this in the first place. Let me just get some blank lines down here. Other value is a float that equals 5.7, right? So when C++ was first, well, let's not talk about C++ here. Let's talk about this language. In this language, you don't particularly need constructors most of the time. So for example, if you've got a simple data-only object and you want things to be initialized at certain values, so I've got this thing, right, and it's got an int that's 42 and it's got a float that's 5.7. This is a declarative way of initializing those, right? And you don't need to write a procedure that initializes those values. And almost everything, at least in the kind of code that I want to write, is stuff like this, right? So most of the time I don't need constructors, I don't want them. And life is simpler when you don't have to think about them, right? However, I did come up with a couple cases, even for my own programming style, where I found that I wanted them. So let me go here. So here's a string builder that I use, like all the print statements that I've demoed and all that kind of stuff uses the string builder. And I'm always trying to minimize how much allocation that happens, right? So the string builder has a linked list of buffers, right? Each buffer is some size, which is set to 16K by default. You know, and then there's some other stuff for tracking where you are in the buffer, and it's a typical thing that you've seen a million times if you've written this kind of program. Like as the print function goes along, it fills a buffer, and if the buffer runs out, it allocates a new one and sets the next pointer, right? Now, the typical case though is that strings tend to be short. If you're creating them, they tend to be shorter than this buffer size. So you don't want to have to dynamically allocate if you don't have to. And so this string builder has a buffer already stored in it, right? And then if you need more buffers, then where do they go? Oh, they're just chained off of oh, I think there's a bug in here. Anyway, I'm not actually storing all the buffers. I think my destructor is buggy. Anyway, the point being that you allocate more buffers and you make a linked list out of them, blah, blah, blah. So when I create one of these, I want this current buffer to be pointing basically at this, right? But then I want the option to point it at a later buffer later on, because this always points to sort of the last buffer in the list. There's sort of two ways you could do that, right? So one is you can have this string builder, and I can have, you know, in this file, I've got some API of what you do. So I've got, you know, expand the string builder, which allocates a new buffer, or append data with some data pointer in some length, right? Or, you know, convert it to a string and all that. And on every entry point, I could check an initialized flag on this guy, and if initialize is set to false, set it to true, and then set the current buffer to the base buffer, right? So you would never need to construct it explicitly, but if I needed to use it, I could set the pointer. The problem with that is it's error prone for me as the person writing the library. And it's also discourages what I think one of the fundamental philosophies of this language is that, you know, all these things down later in this routine are not methods encapsulated inside this struct that only I am allowed to write. Like the idea of the language is, look, if you have a different way that you want to treat a string builder, then you can come along and just write functions on it, and they have just the same amount of authority as any functions that I wrote about the string builder, right? And that starts to be discouraged if in your own code you have to start maintaining this kind of invariant that may not be explained to you, right? And it may not be that simple. Like initializing current buffer, if it's set to null or something, is not that onerous of a constraint, but it only gets more complex from there, right? And so every once in a while, it's just a good idea to have a constructor. There's also performance impacts of that. There are a small performance impact, but every procedure that I have down here now has to check that pointer, which has a runtime effect, and it has to contain a procedure called to the initialize routine, which increases code size. So you'd rather not have all that. Although the code size argument is, there are counter arguments to that, for sure. In fact, I'm going to rescind the code size argument. I don't think it's a good argument. But anyway, that's a reason why you would like a constructor, right? Is in cases like this, you want to initialize things. Now, that's still a relatively rare case. I find that most things that I create don't, I don't love dynamically allocating memory all the time because that's slow. So most of the structs that I create don't really want a constructor like that. However, let's say you're writing an API for people to use, and you start out and you've got something like this, right? And it's got really just regular data members that don't need very special initialization. But you want your API to be forward compatible, right? Because you want people to be able to use it and upgrade to the newer versions of your library without having a problem. Well, you run into a conundrum, right? So the conundrum is the following. One of the nice things about this language is that if I'm just sitting along writing code and I say thing is a thing, right? And then I do something with, a pointer to this thing or whatever, this is initialized. And this was all I needed to do to initialize these to this value. And that's very convenient, right? But if you're writing an API and you want the API to be forward compatible for a long time, then you want to make sure that this code that I wrote down here remains valid if you change thing around, right? So one simple way you might change thing around is you might put a string in there, right? Okay, that works fine. No problem there. It's bigger now, whatever. Nothing I did depended on the size of this or the fact that there's a string member. But if you have a buffer now, like say, say we have an equivalent thing, right? Or say you've added some memory that needs to be allocated when this thing starts up. I don't necessarily think that's a good idea, but some people do that. Or let's pick a simpler one, a serial number, right? Say you've got some int and it's being counted up every time you construct one of these, and that's necessary for something in the program, right? As soon as I add one of these things, this code no longer works, all right? So now if I'm defensively creating my API, then even though my thing might be super simple, I have to require you to init the thing. Because I don't know if someday I'm going to add members that need explicit initialization. And what's even worse is if I'm going to be robust against errors, I need to make sure you initted the thing before you used it, right? So then I need to go in the rest of my API to thing, and I need to make sure that you initialized it. So even if I don't care, I need to add an initialized, right, value that's set to false, and that this sets to true and does nothing else, right? And then my other code has to take on this complexity and make sure you called init on it, just so that one day, if I actually need you to init it, then it's okay. And I need to do this with every single data structure, which is crazy, and it destroys this simplicity that you get of just being able to do this, right? So that is my justification for why I'm leaning toward constructors being a good idea. Now, again, I'm not totally in that department. Like, I might change my mind someday. But right now, I'm strongly enough in that category that I went and did all the work to implement constructors and destructors. So, whoops. So now let's talk about some other things. We're not doing it like C++. So what I'm going to show today is tremendously simpler than C++ constructors. And let's just talk about the reasons why so that people aren't so confused about that later, right? So first of all, this is not trying to be an object-oriented language. So C++ has weird stuff about, inheriting constructors and inheriting destructors, and those work differently from each other. And the order in which constructors walk substructs versus the order in which destructors walk substructs, none of that applies because we don't have this paradigm of objects in the same way. You just have structs, and structs may have substructs, and that's it. So all that complexity, there's no, there's no multiple inheritance. There's just inclusion of, substructs and so on. So the semantics are boiled down to a much simpler thing. Wizard of West March asked a question. Let's answer that question. The answer is kind of involved, so let's answer it at the end. Now, the other thing that differs what I'm doing for C++ is that the way constructors work in C++ is based on some ideas that are related to OO but different and that are more granular, right? So, for example, there was this idea, even in the early days of C++, that if you're going to construct an object or a data structure or whatever, then while you want to prevent bugs of somebody using that while it's in an invalid state, right, while it's not constructed yet. So the most surefire way to do that is to ensure that there is no way to express an invalid state of this object. And so, if it needs 27 parameters, then you just make a constructor with 27 parameters. And by the time that constructor is done, then this very complex thing is initialized, and then you can use it fearlessly. That was the idea. I think that has proven to be a bad idea. Every time I've tried to do something like that, it became a dismal failure because the complexity is just too high of what's being crammed into this constructor. And, constructors fire at weird times, and you don't necessarily want complicated things to happen at those times sometimes. And it's just like, in complex systems, it is often a lot easier to let things be in an invalid state for a while than to try to force them to be in a valid state by like cramming everything to need to happen all at one time when some of it's not ready to happen yet. So this has just been my long-winded preliminary explanation to justify why I'm going to do a relatively simple version of constructors and destructors. And so with that, let's start looking at the code. Let's actually compile and run it. Let's prove that this compiles. Boom. Let's run it. Hey, look, it's another boring. Oh, let me clear the thing. And so there's no ambiguity about what's the output of the program. It's just doing a bunch of boring prints, and as we often do, we'll run down and look at this. So we're going to start with this section, basics. And this is just showing that there's constructors. So I have a thing. It's not unlike the thing that I showed before. It's just got a couple values, and it's got a constructor and a destructor. And the way I define those is not by using the name of the class, like in C++, because you might want to change the name of the class, and you don't want to have more edits than you need. So it's just a constructor and a destructor directive. There's only one, first of all. You can only ever specify one constructor and one destructor for a struct. We'll talk about why in a little bit. Well, I've already mostly talked about why, but we'll elaborate on that in a little bit. So here's a construct thing. It's just a regular procedure, right? It's not defined in this guy anywhere. And I say, hey, I'm using this thing, and I'm allocating mem, and I'm printing, the address of this thing, right? So a constructor, instead of being declared in the weird C++ member way, there's no members functions in this language, right? So it's just a constructor takes as its first argument a pointer to the thing it's constructing, right? And then here's a destructor as well. It's freeing memory and saying destructing the thing. And, well, we don't actually destruct until later, but so we're constructing this thing at this address, and then we print done. Now, in addition to just being called statically by the program, this language has a lot of metadata availability in it, right? Oh, this is not incomplete anymore. I did that. I'm demoing that later, so that comment should not say incomplete. So you recall that we have these type infos that describe the layout of anything. So for any struct, I can get the type info and I can print that. And so that's what this is. And you'll see here, there are fields called initializer, and that's a procedure with a pointer to the code, and then constructor and destructor, which are pointers to the code. Now, what are those? Well, the initializer is the thing that sets the value of this to 42. It's the thing that sets up all the constants that are sort of declared in the declaration of the struct. And then the constructor is this part, right? And the destructor is this part. Now, one reason why I separate those, well, there's two reasons. One is that at runtime, you may care a lot about which, you may want to do one and not the other, right? But the second reason is just that you may want to mix and match these routines. So you may want to reuse this for multiple things. We'll show that later. And you may not, well, it'll be obvious. All right, so anyway, we have this info along with all the other things that a type info contains, right? Like the name of the struct and what all the members are and who it was polymorphed from and all that good stuff. All right, so here's a thing too, and it's another thing, and I'm starting it out uninitialized. And I'm mem setting it to 0 because that's what I felt like. And then I'm going to print it. So we've got a thing 2, and its value is 0 and its mem is 0, right? Because I mem setted the whole struct to 0. Then I'm going to cast the initializer to the appropriate type, right? Because it's basically a void pointer on the type info, because the type info is the same for all structs, so it can't know what type this parameter is supposed to be. So we're basically telling it what type this parameter is supposed to be and that it doesn't return anything. So we're basically casting these to the types that we want to use, and let's call them. So we call the initializer explicitly and print it after the initializer. And now value is 42 and mem is 0, right? Because the initializer didn't, or the mem didn't have a default value in the struct declaration. Then we call the constructor, and that prints constructing thing blah, and that's being printed out here. And then we print it after initializer and constructor, and you can see that mem now points to something because it got allocated, right? So first of all, this is, well, yeah. Now, we're going to show a more sophisticated version of using the pointers off this type info later. I just wanted to show that for now because people tend to ask, oh, how does this tie into type info and stuff? But that's actually not the most convenient way to do it. If you know the type that you're dealing with at compile time, then you can say constructor of, initializer of, and destructor of, right? So I get each of those, and those are constants, right? So I use colons to get them, and then I print them, and here I'm printing them out, and you can see that those are all valid procedures. Now, these by themselves, the fact that you can get these pointers explicitly and that they're just regular pointers means that you can do whatever you want with them. So if you've seen previous demos, you'll know that this language used to have new and delete operators the way C++ did and the way other languages do. And I did that way back then because I didn't really know what else to do. It was early in the design phase, right? But once you have this stuff, you have everything you need to implement new and delete at user level. So I said, all right, screw it. We're taking those out of the language and we're going to implement them as library routines. And then if you want to do something different in your new or your delete, you can just copy the library routine and mess around with it, right? So here I'm going to new a thing and I'm going to say t is blah just to prove that it worked. So there you go, thing with another memory location. I'm printing out the value, I don't know why explicitly, and then I call delete down there. And it's destructing thing, well, I never printed the address of this, but it's going to be this one, right? Because this is the one that's on the heap. These are the ones that's on the stack. So for these guys that we declared on the stack, they are each getting destructed down here at the end of the block. And this one is on the heap, which is why its address is a very different number from these two. So let's take a look real fast. We won't dig into it very far, but let's go into here and see how new and delete are implemented. So new takes some default arguments. So it wants to know the type at compile time. That's what T is. $sign means we need to know it at compile time, right? And we need to know if we're going to initialize it or not. And then this is the caller location, which you can use for debugging. I demoed that, I think, last time. And we just allocate some memory. And then if you want to initialize it, you know, if it's an array, we run over the array and construct everything. Otherwise, we just call the constructor once on the memory, right? And so construct is, for example, just gets the initializer and the constructor, right? And it inlines them, right? So you might think, oh, breaking this into initializer and constructor has performance penalties because now you have to call two functions every time. Well, no, because I'm saying inline call this and inline call that. So if there's an initializer on the struct, we call it, otherwise we mem set it to 0. So if you declare a struct and all members are 0, then the compiler will tell you that there's no initializer. And you get null back when you ask for it, right? Which is why I'm doing this. And then delete is the same, right? So it's simpler because you don't really have to do a lot. So I just say, what's the destructor? If it exists, call it inline and then free the pointer. And of course, this is polymorphic, so it runs on any type, right? This is polymorphic, so it runs on any type. Okay. So is overloaded the next thing? Yeah. Okay, so the fact that you declare the constructor here might, if you start to think about what is the closure of that with all the other features of the language with regard to procedures, you might start asking, do those work? And the answer is yes, they all do. Almost all. There's one I got lazy about and didn't implement yet, but probably nobody will remember it and ask me about it. Okay, so for example, overloads work fine. So here I've got a constructor. I'm saying the constructor of entity is init, and I've got like 4 versions of init here that take different sets of arguments, but only one of them takes an entity pointer as the first argument, right? So, and it sets the name to hello sailor. So I'm just declaring an entity. The constructor gets called, and then I print entity is blah, right? And so that works. Entity is entity with hello sailor, right? So that's fine, and that doesn't depend on order of declaration or anything. It works fine. It doesn't, these could be in global scope or mixed scopes. It all works. It all works exactly like I demoed overloading in previous times. So instead of just listing an identifier here, you might just list the text of the procedure instead, right? So here I'm showing that. So I've got an entity 2. And I'm doing this thing where you count up the serial number every time. And it's got a constructor, and I didn't want to refer to an external procedure. I'm just writing the body of the procedure. So, you know, there's an E that's a pointer to an entity 2, and we're using it so we can just say, just like a this, serial equals get next serial. And get next serial, this counts up this global serial number and returns it, right? And then the destructor just prints what entity serial we're doing, and I make 3 of them. A, B, and C, and if this is working correctly, they should have increasing serials. And indeed they do. 1, 2, 3, right here. Now, I should have demoed just straight up polymorphism, I guess. I forgot to do that. But that works. And you know that works because frickin' quick lambda works, which is a syntactic sugar for a polymorphic lambda. Right. So here's an entity 3. Again, it's got a serial number, and it's got a constructor, and the constructor is a quick lambda. We just say, we take x, which is the pointer to entity 3, and we just say x.serial is inline get next serial, right? So very brief little constructor that does what we want. And then we do D, E, and F as entity 3s, and that works as well, right? So again, if you're from some frou-frou, heavy runtime non-statically typed language, you might think that this is not a statically typed procedure, but it is, right? So this is syntactic sugar for a polymorphic argument that's got, you know, some x of some type t, and every time you call it, you know, it gets compiled at compile time for that type, right? So this is just as strongly typed as, you know, in the end as C, right? So it's like a C++ template function in that same way. There's no runtime magic happening here at all. This is all compile time. Okay, so let's talk about reuse. So here I've got a function called compute. It's a quick lambda, so I map s, and I just say whatever s is, I'm going to set its z component to x squared plus y times x minus 3. So I'm just doing some goofy polynomial of the coefficients of this thing. And then I want to reuse that on a bunch of things. So I'm saying, hey, the constructor of math int is compute, right? And math int is some type that has x as an int and y as an int, and z is the same type of x, whatever that is. And I'm declare a as a math int and show that compute works on that, right? So here we go. So z is 18, which is what you get when you evaluate this on 3 and 4. So again, for all these examples, these first two are always going to be 3 and 4 because the constructor doesn't change that at all. Only z gets set here, right? So then we have a float version, and we're using compute, which is the same declaration, right? But it gets polymorphed differently in this case. So here we've got the float version, 3.0, 4.0, 18.0. And we've got a mixed now where x is a float 64 and y is an int, right? And we do the same thing. So this is just to show that, you know, the interoperation of polymorphism with constructors. I believe yeah, we're here now. Optional argument usage. So up till now, I've been showing constructors that have one argument, but like I said, it interoperates generally with procedures. So here again, we've got a math int. It does a polynomial again. Someone's asking, I'll answer that question about omitting the x dot again in the Q&A because it'll derail the discussion right now. And let's just hold all questions till the end. It's more organized that way for people who are going to watch on YouTube later. Okay, so here we've got, and also it's hard for me to notice questions as they come up on the chat. So this is a slightly different function though, because instead of hard coding all the coefficients, we're now passing them in as default parameters. But this still works. So we say the constructor is compute, and so when I construct this, you know, it must be running something, and what it's doing is it's passing the pointer to the math int as m, and then it's just taking the defaults for these because constructors don't supply other values. Here we go. Right, so after construction, A is blah, blah, blah. So now I'm going to call the same routine to show that there's no magic constructor juice in this function, and it's just a regular function. I'm going to call this function with different arguments for x, y scale and trailing constant, and I should get a different answer. So I call it with those, and after calling that, yes, I get a different z. So that just goes to show that unlike C++, right, the constructor doesn't have other weird code wrapped up in it. You can just call that anytime you want because it's just a function. There's no weird constructor juice. All right. Now you might ask, well then, how do I construct A and pass different values for these guys at construction time? And the answer is right now I do not give you a syntax to do that. And the reason is that I want to minimize use of constructors because I think they're a complication that I would rather not have. And so I think if you know that you want to do something more interesting or more involved than the default construction, then just call a regular function on it. Don't try to use constructor magic. So yeah, there's no like this kind of thing, right? In fact, actually, the syntax for this right now, or the syntax for the language, would interpret this as parameters to this type, right? Because when you parameterize a struct, you supply the parameters with parentheses. So yes, that isn't a decision that some people may disagree with, but I'm trying to keep things as simple as possible while being as feature-rich as possible. That said, it is not a very large modification to the language to provide a way to give arguments like that. So if we decide it's super useful, we can do it. But for now, I'm just being super minimal. Well, along certain dimensions, I'm being super minimal. So here I've got a proc that's varargs, and in fact, it's not even varargs of a pointer to somethings, right? It's a vararg of any's. So if you remember, in one of the very first demos, I showed what happens. Any is a way of wrapping an arbitrary type so that you get the information about the type and a pointer to its value, right? So the constructor can be this varargs proc, right? So I make a something, and so first the constructor runs. So let's show that. We say varargs proc got 1 arguments, and for every argument we print it out, and it just says x sub 0 equals this, which is the pointer to the thing, right? Here, just to show that it does different things, I'm calling it with this struct by value now, which is different. The constructor passed a pointer to it, and this is passing it by value. And again, it shows that, and here I'm just passing it with a pointer to show this is the same as the constructor. For some reason, when I did this demo, I was brain dead, and I just didn't show it as a full varargs proc. So let me do that. I'll go varargs, not varargs, vararg proc, 1, 2, 3, hello, sailor, 69105.0, and something, right? Just to show that it should take all these things and, oh, what did I do? Oh, at the bottom of the file. I left this junk at the bottom of the file. All right. For a minute, I thought I had a, let's clear. For a minute, I thought I had a dreaded like demo failure. Laser no good. Okay, where is it? Where is it? Okay, so here we go. Just to prove that this is a regular varargs proc and there's nothing crazy happening, we're printing all the arguments. It knows the type. It just all freaking works, right? So that's great. Great. Okay, I think next is array demo. Or array test. So we've got these constructors. They work when you declare one of them, for example. Okay, actually, let me make a point before I talk about this. There is only one time that constructors ever fire. In C++, there's at least 2 times, right? In C++, if you declare something on the stack or you say new, that's when the constructors run. But we don't have a new in the language. It's just a standard library routine that calls the constructor. So the only time a constructor will ever automatically run is when you declare something on the stack, okay? So we declared things as a scalar on the stack, but here we're just showing that you can do arrays of them and the constructors will work right on the array, right? So here, we've got a constructor that just sets the value to a random number and prints something, prints the address, and the destructor prints the address. And here we've got an array of 4 of these entity 4s, and we're going to see those constructors fire off. In fact, here they are. Boom, 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 boom. We have random values each time. And then we print a sub 1 just to prove that it's there. And then we do a 2-dimensional array just to show that that works. So here's 16 guys, all with different random numbers, and you see the addresses going upward in a very orderly way. And here we print sub 3, sub 2. So that works as you would expect. Another thing that you would expect to work is having a struct that contains structs. So in fact, here's a bag that contains an item, which is a thing that has a constructor that prints something out. And we've got an array. We not only have 1 by value, we've got like an array of 6 by value. And then the bag itself has its own constructor, right? And so, what you might expect is for the constructors of these to fire and then this one to fire, and that's exactly what happens. So where are we? Okay, so here we're constructing one of the items and then this array of, how many is that? Oh, it's not running 7. Maybe there's a bug. I'll have to look into that. Anyway, I feel like it should print 7, 6 for these and 1 for this, but I only see 6 here. Unless I'm hallucinating. Someone's saying that 4 entity array initialize the first 4 entities twice. No, it didn't. Just once. Right. This is the, oh, you mean the two-dimensional one? No, this is the one-dimensional array here. This is this one. This is this one. And then these are the destructors. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Right, you would expect 20 destructors, and that's how many you see. So these 16 fire, and then these 4 fire. Or is it the other way around? No, it's these and then these. So that works. However, I think there's a bug here. I think there's legit a bug, and I don't know why it happens. So I'm going to make a note to look that up. But anyway, so here we've got this array of 6 other items, and these constructing items get printed because those are being constructed. The initializer sets the name to an item, and then the constructor for bag runs, which sets item 2 to hello and item 4 to sailor, and then we iterate over all the items and print them out, and there we go. And the fact that this happens after these shows that this constructor ran after these constructors. Someone is still... Oh, wait. No, you're right. Okay, yeah, no, you're right. There's a bug, man. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, okay, that's not right. Okay, well, I've got 2 bugs I have to fix as soon as the demo's over. Let me write this down. I should have tested more thoroughly before the demo. Good eye to catch that. Because I was running that for a long time and never noticed. Because the numbers are different, and you just scan down and you're like, oh, they're different. But basically, the point is, if you look at the addresses of these, they're the same as the addresses of these. And there's 20 here. So like, yeah, these four are running twice for some reason, and it's just a bug. Like there's an off by 1 in, you know, when I run an n-dimensional loop to generate the code to call these constructors. So it'll be like a 5-minute fix, but it's a bug. And then this one, I don't know why that's happening. All right. We'll have those fixed by the end of the night. So, so we have substructs. What are we demoing next? Uninitialized. Right, so this is a little bit like the thing, because early on I demoed something that's explicitly uninitialized, but this is just to show like, hey, that works. So this runs a constructor for thing. This doesn't run a constructor for thing, but now I'm making an alternate constructor that allocates a different amount of space, right? So if you remember, construct thing allocated 1,000 bytes, and here we're allocating 2,000. So we're calling those. This is a little bit redundant with what I showed. It's just to show that if you want greater control over what exactly happens, you can say, no, don't construct this one. I'm going to construct it, and then run your own code on it, right? That's all that is. So I promised I might fix the bugs live later on in a live stream. We might do that. I just don't want to derail the demo to fix the bugs because they're relatively trivial bugs, I say now. Okay. Dynamic instances. So I promised before a more sophisticated version of using the type info. So this is not like a fully real world example, but what I'm doing is I'm saying, you know, let's say we deserialized some information about what we want to construct, right? So we started with no compile time knowledge of what the type is. It's a common thing that might happen in a game engine, right? You load a level that's got some information about some entities, and you just have to like read in what all the entities are, and you have to construct them in the world, right? And how do you do that in this system? So I'm starting, let's just say somehow we were able to map to an index within the type table of the program, right? So there's various ways that you could do that, but we managed to do that. So I'm just going to pass the index in the type table to this procedure called dynamic instance, right? And just show. So here, first we know that we're constructing a thing, but dynamic instance doesn't know we're constructing a thing. So it has to get from the index back to the type. So here, and again, this is just a slightly different version of the things that we've looked at. So we get the type table, we get the type info out of the table. So this is the same as what you would get if you said type info of a particular type. We're asserting that we passed a struct because that's all that we want to deal with here. And then we print the name of the struct. So calling dynamic instance for struct thing, so you see that that worked. Then we allocate memory equal to its runtime size, right? If we ran out of memory or our allocator, didn't give us any, then we return failure. We get the initializer in the constructor. Here, I can't use hash if, and I can't use : because these things aren't known at compile time, right? So here I'm just saying read this field off the type info struct, right? Type info struct. Give me the initializer and give me the constructor, and then we print out what they are. And so this shows that that's working. If we have an initializer, use it, otherwise memset to 0. And if we have a constructor, call that. I'm not bothering to inline them here. And then we return that. So this is just, at the end of this, we print out the thing, and you see that it's correctly initialized, the value is 42, and the memory is blah, blah, blah. So we went from no runtime knowledge of what we were going to construct to a valid instance of this thing, and we did it with basically no code of our own, right? We're just using the metadata provided to us by the compiler. This is the kind of thing where if you were going to do this in C++, it's painful. It takes a lot of work. All right, and then just to prove that that works, let's do it for a second type. So I have this type called Globo up here. It's got a 1, 2, 3, 4, right? And it's got different. It says pre-main and post-main constructor and destructor, but here we're not doing it in global scope. That's a thing we'll talk about in a second. So it says pre-main constructor running, but it's not running pre-main. But just look, we're constructing a Globo, right? Now, this is to show that the constructor correctly ran as well, because the value is 99, which you might say, wait a minute, the value is supposed to be 1.234, but actually the constructor pokes a 99 in there. So that's where that comes from. Okay, now let's talk about something more complicated regarding optional arguments. In this language, when you call a procedure with optional arguments, the caller fills them in, right? So, it's not like some languages might do a weird thing where you jump into different parts of that procedure based on which arguments you are providing or whatever. We don't do that. What we do is the caller provides all the arguments, and if some of them were optional, then the compiler just fills them in the calling convention, and so on. So we're going back to this example where we have this local math int thing, and we've got this constructor compute just like before, and it's got optional arguments, right? So we already did this, and here. I'm making the point that, how do I say this? Okay, if these constructors only ever got called at compile time, there would be no problem at all, because the compiler can just, when it calls the constructor automatically on a local math int, pass these arguments, right? However, at runtime, if you're going to do a thing like we just did with dynamic instances, you're going to do something like this. If there's a constructor, call it. You don't know if there's default arguments or how many there are. You don't know anything about this constructor, right? You don't know what to pass here, and there's no way for the compiler to do it. I mean, we could do something really arcane and weird. That'd be super disgusting, where the compiler recognizes a special function. We're trying to stay away from that kind of thing, right? The other thing that could happen here is there could be some stuff on the type info for the struct that gives you the type signature of the constructor, and then you would have some massive library routine that you call to like poke in the correct default values that uses that information to figure it out. We could have done that. That would have been a viable way to do it. I didn't like that. It seemed too complicated. So instead, what happens is when you have a situation like this, where there's a constructor and it's pointed at something with more than one argument, then in addition to compiling this constructor for you, we also make a forwarding constructor that only takes one argument, so that if you're going to call it at runtime here, then you only ever need to worry about one argument. And so the thing that we actually get here for this constructor is a forwarder that fills in these arguments and then calls this guy. So here what I'm doing is I'm printing compute, which will give us the address of this thing, and then I'm printing the constructor of local mathint, and these will be different addresses. And this is just to show that this is different because it's the forwarder. I should have maybe done this in other cases where they're the same, but whatever. You can imagine them being the same. Where are we? Here we go. So this is like blah, 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 CF210, and this is blah, 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 CE590. So different procedures in different places. And again, to show that that works, I'm getting the index in the type table. I'm calling dynamic instance and then printing it out. And so we get a valid local mathint back with the correct computation performed. And that worked by calling into the forwarder, which then called up to the full constructor. Okay. New and delete replacements. I already basically showed this because we looked at new and delete. There's a question of what should it look like to make arrays of things in whatever. For now, I was just goofing around with making a thing called new array and delete array. So new array basically does what you expect. You give it how many things and the type and whether you want to initialize, and it allocates that many things, and blah blah blah, and calls construct array, which just iterates over the thing. You can imagine unrolling this loop in certain conditions and whatnot. But this is just a very brain dead implementation. I haven't gone, well, that's about every case that you could cover, because if you start to think about, oh, what if the things in this array have substructs, and what if they have subarrays? Those are already sort of handled by this stuff, I think. Actually, no, they're not quite. Multi-dimensional arrays are not quite handled by this. A small change would fix it, but structs with substructs and all that are handled by this current code, because when you call the initializer for a struct, it initializes the substructs. When you call a constructor for a struct, it calls the constructors of the substructs. I just, it's a small amount of work to get this up to like a full thing that handles everything, and I just didn't want to bother yet. I'll do it when I need it. The other thing to point out is that you have the freedom to not call destructors if you don't want to. So here, I made a new array of 5 things, and then I just freed it without calling the destructors, and that works because, again, the code for the destructor is not tied to memory deallocation in any way. It doesn't know anything about deallocation of the block of the thing itself, right? So you're free to manage it in any way you want. And here, this is just another example with bag and all these constructors, this subarray of things, and showing that that works. So, here we knew a bag. and it's got the items. It's still getting only 6 items. There's just an off by 1 in array iteration. That's all it is. Okay, and then we do the same. It's the same code as before, so it's got the same output as before. Now, I had these globos. The last thing I print at the end of main is just to show that these globos are initialized. And what are those? Well, I have an array of 4 globos in the global namespace. And just as in C++, these will construct and destruct correctly. So when the program starts up, we'll see pre-main constructors running, and when it shuts down, we'll see pre-main, post-main destructors running. So those are the destructors. Here's the constructors. And, you know, we print out the value of one of them just to show that it's initialized. So that is exactly what you would expect as well. I've toyed around with the idea of allowing you to set a build option that prevents the automatic calling of pre-main and post-main stuff and enables you to call them yourself on your own time, because you might want to, you know, do something at the beginning of main before these things get initialized. I haven't done that yet. I'm not sure if it's necessary because my opinion is sort of just don't do anything order dependent in your global objects, but we'll see. We'll see if it becomes necessary. And that's it. That's all that I wanted to show. It's pretty straightforward, but the reason of, you know, I wanted to get this out of the way so we can do awesome features next time. So, are there questions about what was shown here? Someone is asking, can you write constructor bake values in my function default arg equals 2? Yeah, you should be able to. I haven't tried it. Let me try it. Is there any reason why that wouldn't? Oh, you know what? I might not parse that. And I'm not sure if bake values works. I might have let bake values rot for a while. Let's see what happens. Let's just, at the end of main, let's just, first of all, f foo is takes a thing and an int, and we're going to say x.value equals y, right? Say foo thing is a thing. Foo of foo thing 77. Print foo is, okay, this won't do anything exciting yet. This is just boring, right? Okay, foo is blah, blah, blah. Wait, what? No, I don't want to print foo. Let me put some new lines after this to make it easy to spot. And let's get rid of the globos for now, because, well, then we don't need to do this. Okay, so I want this to be the last thing in the output. I didn't want to print foo. I wanted to print foo thing. Thing. All right. Oh. Fine, we'll leave the globos, whatever. All right, so this procedure works. Now, I'm going to say bar is bake values foo y equals minus 69105. Let's just see if that even works. Wait, that's the wrong syntax. I think it's bake values foo. I think it's that. It compiled. All right, so now let's just see if this works. Bar thing is a thing. Bar thing. So we've curried, functional language people call this currying, right? So we've curried this procedure down to one with fewer arguments that's hard-coded. And then I'm going to print bar thing is this. Okay, 69 minus 69.105. Now, try me is a struct. No. Let me just make a local struct called thing. Right? This is just going to shadow our other thing. Okay, this is all fine. It still works. So the reason I'm shadowing it is so I can set the constructor without messing with the rest of the program. I don't know if I can do this in local scope. Let's see what happens. Oh, okay. It's complaining that it must be a constant procedure. The thing is, oh wait, bar thing, that's not a procedure. Bar. Okay, well that worked. All right, so if I just do this, let's just get rid of these. And we're going to say t is a thing, print t is blah. So if this works, then this is just going to get the default constructor. The default constructor is bar, which should set the value, right? So let's try that. So that works. So then let's try the original question, which is just this. Instead of saying constructor bar, we say constructor that. I don't know if I parse that is the only thing. I guess I do. Okay. So that makes up for me having a bug earlier in the demo, the fact that all that worked the first time is great. Okay, now I'll look for other questions. I feel like I want to include that in the main talk, so now I will look for other questions. Would it be better, rather than implicit constructors, to error on instantiating a type and less return from ordained methods? Well, so the thing about that is fine if you're like D or whatever, and you feel like objects should be allocated off the heap all the time. Then you can call something that returns you something. But often if you want to have fast code, you just want an instance of something on the stack, right? Maybe with a different syntactical way of doing things, that might be a natural thing to express. I don't know. If there were a natural way to do it, then maybe that's better than constructors, right? If you could error if people got something in an invalid way. So that, yeah, I mean, if we come up with something like that that seems strictly better, then I'm all for it. How do multiple return values tie in with the concept of constructors, destructors? Well, constructor and destructor invocation just ignore return values. So you could have a procedure that returns things and the return values just go nowhere. Any reason for against allowing multiple constructor in the struct for overloading, so it's visual while viewing the struct? Well, you could only have one constructor in the first place, and the compiler only calls it with a pointer to the thing. So, like overload resolution, the point of that overload resolution that I showed was not that those other things were also constructors. They weren't. They were just other procedures with the same name, right? It doesn't make sense to declare more than one constructor for a thing. because only one can ever happen. And it's an error, actually. You'll get the same like ambiguous procedure call type of error that you would get if you called overloaded procedures with arguments that would be valid for both calls, right? It says, hey, I can't disambiguate this. Is there a way to prevent the destructor from running? Seems like it always runs at the end of scope, even if you manually free. Yes. I mean, by yes, I mean, yes, it always runs. I've toyed around with the idea of being able to say, like, put a no destructor directive on a declaration. I've toyed around with the idea of that if you explicitly uninitialize it, then you should explicitly destruct it, and then maybe you can do that just with defer at the construction site anyway, so you don't forget. I'm not sure which one of those solutions is better, which is why I haven't done either of them yet, but either one of those ways of doing it would be pretty straightforward and simple extension of what's here. Does the built-in dynamic array have a destructor that frees the memory allocated dynamically? Yes. The thing for which constructors and destructors are most useful in C++ are smart pointers. Can they be done in your language? I do not like smart pointers. In fact, I very, very strongly, mega strongly dislike smart pointers. I don't think they're a good thing, so I don't think about them very much, honestly. I don't use them when I program ever. But, you know, I've demoed operator overloading, and all smart pointers is, you know, a templated type with operator overloading, and we have all those facilities. So I presume that you could make a smart pointer with the functionality that's already here, but I haven't done it. If you can subvert auto invocation of constructors, then the argument that constructors help with forward compatibility doesn't really hold. No, I disagree. Look, the goal isn't to prevent people from like, if people go out of their way to do something weird, then they did something weird, right? That's fine. What the goal of this is to make sure that the straightforward thing that you write, when you're trying to write code that's correct and does the obvious thing, remains correct in the obvious thing later. That's all I'm trying to do. If you're going to avoid calling the constructor for some reason, then you probably have a good reason to do that. And as soon as you step into that territory, then you're taking it upon yourself to maintain that. Like, okay, maybe you're making assumptions that are going to break when that API changes in the future. But you know as soon as you do something weird that you're stepping into that territory, right? So this is not a training wheels language where we prevent you from ever doing something wrong. But we want to prevent stuff from just randomly breaking for no reason, if that makes sense. Oh, I forgot to talk about copy. Oh my God, okay. So right now, oh God, this is important. I may have to edit this onto the end of the other thing. So there's a whole thing about operator equals, and my choice right now is that operator equal does not call destructors, it does not call constructors, it does not do anything that it wouldn't do to a so-called plain old data struct. And the reason behind that is that I do not like the disgusting quagmire that happens in C++ as soon as you have constructors. Like, you know, I mean, the fact that operator equals does constructors is where you start having this need for, you know, move semantics and emplacing and all that stuff. And it's a large amount of complexity. And what I would rather do, and I'm not sure this is the right decision, But my decision so far is, if you want that complexity, then you opt into it instead of trying to opt out, right? Which is to say that if you're going to make some big abstract container type, and you want it to call constructors and destructors when you assign things into the middle of the container, then you call the constructor explicitly, right? Equals will not destruct the thing that you're assigning on the left because there are too many times when you're doing performance programming when you don't want that to happen. For example, you don't want to require that this slot in this hash table contains a valid thing. Because if you're trying to make fast code, that could be uninitialized memory, right? Or let's say a dynamic array that expands. That could be uninitialized memory. It probably is uninitialized memory, and you want it to be, right? So my approach so far is that rather than having all these weird different kinds of equals, there's one kind of equal. It doesn't interact with constructors, and if you want constructors to happen, then you do that explicitly. Now, of course, C++ people would disagree with this, and they would say, oh my God, that won't enable you to build large abstractions and blah, blah, blah. And I disagree. And I also say that that part of C++ is such a dismal failure that we have to try something else because it's crazy how bad it is. So I've opted for simplicity. And I meant to say that during the main demo and forgot. Mr. Fourth Dimension says, one of the things that becomes annoying with constructors in C++ is when one constructor has to call constructors for the members that have constructors, and it is especially troublesome when the order of those members' constructors, I assume you mean that when the order matters. Is there a good way to handle that here? Well, again, my policy is that constructors are only for small things, right? I'm not going the C++ way of, you do all sorts of crazy stuff in your constructor. No, I don't think that's a good idea. So I think that if you end up in a situation like that where there's lots of constructors on sub things and the order matters, then maybe rethink that design because it got crazy. My hope is that naturally, because the language discourages complex constructors, that just won't happen. But we'll see. You know, like I said at the beginning, I don't even know if we're going to keep constructors. So, yeah, we'll see. Does global constructors suffer from something similar to C++'s static initialization order fiasco? Yeah, I mentioned that at the end. It's exactly like C++, where they initialize in an arbitrary order. And so if that order needs to be a specific order, then you're screwed. And again, I'm saying that's fine because you shouldn't have complicated constructors anyway. Constructors in this language are not the same thing as C++ constructors, right? We don't believe in resource acquisition as initialization. That's garbage. So on, right? That said, again, I did mention at the end of the demo that we may provide a facility for overriding when that happens, right? So you could say, don't call the global constructors, I will call them later, and I'm going to do something that needs to happen first, and whatever that thing that needs to happen first, you can make happen. You could probably do metadata introspection on that procedure and reorder the procedure if you wanted to make sure things construct in certain orders. Or, I mean, I didn't want to go, like one obvious solution to that is just put a numeric priority on everything global that says what order it should construct in. But honestly, I do not believe that you should be using constructors that complex. If you want to do anything complex, use a regular function call at a known time at runtime. I'm actively trying to discourage heavily non-trivial constructors. I'm getting some light in here. Can you please explain what your issue with C++ Destructor is? I can't, my issues are so many that, dude, I can't even start. Just forget about it. I'm not gonna get into it here. If you like C++, great. I don't like C++. So. Yeah, name guy is saying uninitialized means no auto-destruct. Seems like a completely reasonable and elegant way to prevent destruction. Yeah, that may be the right answer. The only reason I haven't done it is because I don't know yet. And I only have 2 destructors in the whole Sokoban game, I think. So I don't exactly have a large base of examples from which to make decisions yet. This reminds me, at the beginning I said there's probably a bug in string buffer, so I have to go look at that. Do I really not use smart pointers? Yes, I really do not use smart pointers. I really, really, really strongly dislike them. I don't understand. In fact, when they were first introduced, it was like Invasion of the Body Snatchers or something. Everybody thought they were great, and I didn't understand what the hell people were smoking. Do I ever use a reference counted value? Almost never. I don't find reference counting to be that useful. I do use it in rare cases, like maybe once in an entire game I will use something reference counted, but then I do that explicitly. I don't try to do it magically through a smart pointer. Because it'll generally be a bigger thing. It'll be like, here's some large data. I can't give the exact example I'm thinking of without spoiling an unannounced game, but here's some large non-trivial amount of data. And we don't want to casually take references on it as we pass it around. It's like when somebody grabs a handle to it and when they release it. So yeah, I don't understand what the hell people's problem is that they need smart pointers, honestly. Can you change the order in which constructors, destructors, or struct members run? No, because again, I claim that if that matters, you're doing something wrong. Use a regular function. And again, that claim of mine may turn out to be wrong in time, but we'll see. We just have to see what code actually looks like. How do you prevent double free if you're just doing simple mem copies for assignment? Well, so first of all, you're thinking about a case where somebody has memory allocated off the heap and they free that in the destructor, which I guess in certain areas that's a common thing to do, but it's a very slow thing to do. So I recommend not to do that very often if you don't have to. So I wouldn't necessarily think, in C++, you might think of that as the default thing that your constructor is doing. And here I don't necessarily, because we have other stuff like temporary storage that I demoed and so on. That's preferable to using the heap if it's applicable, right? So first of all, that's not the primary use case, I guess I'm saying. And then secondly, how do you prevent double free? Well, call something on the other guy that says, hey, we took the memory away from you. Set your pointer to null so that when you destruct, it's clean, right? Yeah. Now again, you can start saying, well, if people have to do something explicit there, then your whole forward compatibility argument doesn't work in that case because people won't have done that. And it's like, yes, that's true. But you can only, once you start trying to handle every case, you start getting into ridiculous C++ complication territory. And again, I'm trying not to do that. So yeah, we'll see how it works out. I mean, I'm trying to find the very fine line trade-off of complexity versus robustness, and we'll see. We'll see how this exact combination goes. Someone says C++ class members are initialized in the order they show up in the class. That's true here also. So when I said, can you control the order? When I said you can't control the order, I meant you can't change it from the default order, which is the order they show up in the class, in the struct. Do constructors, destructors have to return void? No. Is the return value ignored? Yes. You might already know this, but I don't think you're recording it. No, I often don't record in OBS. Sometimes I do, but sometimes I just have it be on YouTube, and that's fine. What's wrong with the simple thing equals make thing? What's wrong with that is that make thing can't make something on your stack. It can make something on its own stack, which then goes away, right? It can make something in temporary storage, which it can return to you, and that's fine, but you want things on the stack. For maximum speed, you want things on the stack when they can be on the stack. And so there's not really a way to do that. However, right, maybe, so we were sort of saying this before, but maybe the right answer is actually to do something like that, where you say thing : equals make thing, and say, by the way, pass the stack argument, right? That would be fine. That would get rid of most of this constructor and destructor complication. It would also, however, get rid of the forward compatibility thing that I mentioned before. So there's trade-offs. But again, like, you know, having constructors and destructors is an experiment. What you mentioned and what somebody else mentioned earlier might be a different way to do the experiment. And I'm not sure which one is better. So we're just going to see. Am I against all use of RAII? I can see this being used for stuff like lot guard for critical sections. I used to have defer, but that's more typing. I mean, I do that sometimes. So I have a small number of cases where I do something like that in C++. So I'll have like a scoped mutex, right, where I declare it, and that just means, okay, grab this mutex when you hit this declaration and release it at the end of the scope. Like that, I don't necessarily have anything against that kind of usage. When I say I don't like RAII, what I mean is that I don't like the dogma that that's a good way to do everything, or that you must do everything that way, which unfortunately for C++, they've decided that you have to because you have to be exception safe, right? Which is crazy, crazy. Like everybody should have laughed them out of the room when they said you have to write all your code exception safe. So yeah, you can do that here, and I do that in C++. In fact, let me find somewhere that does it, right? Yeah, so here's a scope block where I grab a mutex and it'll release at the end of the scope. So, you know, I do that. Someone is saying the issue I have with constructor and destructor is that they obscure the flow of your program. You said you're actively discouraging people from writing complex constructor, but it's not a hard and fast rule. People will misuse it. Maybe, yeah. Like I said, I'm not 100% convinced that this is the right decision, but I'm trying it out. That said, people can make arbitrarily complex and nasty code anyway, so you can't ever stop them from that. But yet there is such a thing as the grain of the language encouraging or discouraging certain levels of complexity. And so what I'm hoping is that these can be a feature that live in the background and are rarely used. If that ends up not being true, then we may actively explore alternatives. I frankly don't like the amount of complexity that this adds to the language, but it's not clear to me that there's a better way to do it. And so, yeah, and again, there might be, but unless I figure out what it is or someone tells me what it is, then you kind of have to do the best thing that you have available, right? Oh yeah, WizardOS March. So the question I asked before you wanted to hold off on, would it make any sense as an option, either additionally or in place of constructors, having attributes on data members to indicate they have to be set before using the object as a way to ease updating libraries? So maybe. The problem with that is that making sure that that happens is equivalent to solving the halting problem, which is unsolvable, right? So there will be cases where the compiler can't tell that you set that member if it happens in some function that's getting called in a certain way and blah, 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 right? Now you might say, well, that's fine. You have to do it in an obvious way that the compiler can definitely see what's going on. Then the language semantics have to guarantee that certain things work, for sure. Like you have to know that the program you're writing is correct. So it gets complex, and it's not clear to me what the right answer is. But if that ends up being the right answer, like if there's something like that that enables us to just get rid of constructors, I would be happy to get rid of constructors. Is there a way to force handling of errors that occur in constructors? I don't know what the answer to that would be. Because I don't know, first of all, how you know that an error happens unless you look at the state of the object, which you could do, but then you're in highly, object-specific logic, and then you're just doing whatever you're doing, right? There ain't no exception handling in this language of that kind. There's only panic handling. So there's not going to be like the constructor throws an exception. If you, my advice is to do things that don't fail. Like setting that pointer to the address of the buffer in the string buffer doesn't fail. So it's a perfectly good thing to do. But if you are going to do things that might fail, then it's just regular code. It's just like somebody called in a init function, right? I suppose in that case, they can look at the return value, and in this case, they can't. So maybe there needs to be a way to look at the return value. But again, I feel like if you're going to do that, you should just call a function. I don't know. Would it be possible for a constructor to live in a DLL that the user doesn't have the code for in their current module? Yes. As custom allocators are heavily used in your code, I guess there is no such thing as a strict aliasing rule. I have not decided what my aliasing story is. I don't like the C++ rules about aliasing, but I haven't thought about what might be better. Now, of course, you want something because it matters a lot to the performance of your program whether the compiler knows whether things are aliased or not. But I'm not sure what that's going to end up being. It remains to be seen. Will I include any kind of error handling? Return value handling is error handling. Apart from that, there will be panic handling. Apart from that, no. You can return things on the stack if you remove less from the stack when exiting the function than was allocated when this function was called. Yeah, but that's a little bit bananas. You could do that. Like it puts constraints on where things have to be, but those are livable. And you need a weird syntax. You would have to introduce some weird syntax that says this thing leaves a certain amount of memory on the stack. Which again you could do. I just haven't followed that train of thought to its logical conclusion to know if it's appealing relative to this. But yeah, you could do that for sure. Yeah, the triple dash works inside structs as well. Do I think I could do a stream where I analyze RAII gone horribly wrong? I don't know, man. I mean, I'd rather just give good examples of fast code, which is usually not going to be RAII because RAII is anti-fast software. I don't know. I mean, I've given as much of an explanation as I really want to give about that. It's like, it's really something that you either get from experience or you don't. Like, explaining it is hard. Do I use standard thread? No. No. I do not use std : anything, except in one side project where I used std function because it was a lot easier than, like when you use lambdas, you kind of have to use that or roll your own, and I didn't want to get into rolling that. But I don't like the C++ standard library. I think it's junk. Is it possible that forward compatibility isn't worth the trouble? Why not have the user be required to be conscious of the versions of libraries that you're using? Yeah, that's one thing we might do. Yeah, who knows? Wouldn't the simpler thing be for library writers to maybe add a remind callers of my new explicit init flag, and the compiler would warn callers of all areas they need to check? Yes, it's annoying, but far from hidden breakage in your forked pet scenario. You could do that, but then people need a way to explicitly signal that they paid attention to that and turn the warning off. But yeah, I mean, that's one way to do it. And it's a little more annoying because you're not like assured that your code is right. There's still some manual steps that you have to do when you upgrade a library or whatever. But possibly. But we would need to think about that. How does that exactly work for real? I don't know exactly. Do we have returning structs by value? Yes. Then x equals make x would work on the stack, wouldn't it? I guess, sort of, but you're relying on an optimization. You're relying on an optimization that, you know, that we provide the L value of the final struct to the function, which we actually do. But that, I mean, yeah, come to think of it, that mostly works. Really, the question is just about internal to the procedure. Like right now, we don't necessarily. I haven't looked at how well that optimizes when you're actually, because this struct is going to have many values, and those are all going to get placed into that spot. I don't know, man. I mean, maybe that would work. Again, the forward compatibility argument doesn't happen there. But that might be a solution. Yeah, I don't always think of everything. Someone says, I think if you integrate constructors as a tagged function, it reduces the overhead of the concept, similar to how you can tag procedures. What do you mean? I don't understand what the tag does and how it helps. Can I speak a little about the perf improvements I made to the compiler? I mean, it would have been fun to do those on stream so that people could see, but I did them working at cafes and stuff where it wasn't convenient to stream. It's just regular optimization. I didn't do anything too crazy. You know, it's just I was running telemetry where if you guys saw me using telemetry before, I busted that out again and saw what was taking time and attacked it. That's how optimization goes. Enemy Mouse is saying, I figure upgrading a lib shouldn't be done lightly while writing code without worrying about the possibility of magic here and there is a higher priority. That might be true. That, you know, I mean, let's just see. If constructors turn out to be a bad idea, I have no qualms with ripping them out of the language before we go to 1.0. If there's a better thing to do. So, yeah, I mean, what I would like to do is just, you know, we can see them in the language, we can see how they are, and we can try alternative approaches, and if the alternatives end up looking good, then get rid of constructors would be awesome. Because I do dislike the magic, now we're in a procedure somewhere when we didn't necessarily expect it. I don't like that, and the pre and post main is a little bit ugly, right? Like, oh, some code is running in an arbitrary order pre-main, right? So, yeah. Am I gaming after this? I don't know. I'm kind of tired today. I might just go home. Oh, okay. So as a follow-up to that tag question, I did this for console commands on a demo where I tagged functions to make the boilerplate safety check and calling. Yes, so, but what would that mean? How are you suggesting? Do you mean that there's a safety check that would happen, or what? I'm not sure what the tag would indicate in this case. Is there anything in the language that can enforce a function's purity? Right now, you can do that through a compile time metaprogram, right? You can inspect a function and make sure that it has no references to external things, except, of course, if it calls another function, you can recursively check that one and so on. However, I do think that's important enough that there should be some more built-in things that help you with that, but I regard those as relatively smaller features that will happen later. We've got some bigger features in the near term. You just mean that constructors work through the same system. For something as basic as constructors, like I guess you're saying that the compile time metaprogram would alter the code to insert the call to the constructor if it's tagged. You could do that, but that's a pretty invasive thing to do. Oh, but you mean maybe the library writer does that to make sure that you don't forget, like if yeah, maybe. I mean, so in a way I don't like that because that's even more stealthy than this, right? Like if your library is going to go insert a bunch of procedure calls invisibly into your code, that's not so great. Like at least if there's a constructor, you kind of can know that that constructor gets called. Even like your IDE could draw constructor gets called here, right? In fact, I don't know why C++ doesn't, Visual C++ doesn't do that, for example. It should. That said, some variant of that idea might work out. Yeah, maybe. The scroll bars do not have explosions yet, sadly. Yeah, so it's interesting. So generally about this idea of returning something that's on the stack or so I've been thinking for a while that the semantics of declaring something on the stack is a little bit weird. Like, why is it that way? It's sort of just inherited from C or from other languages, and like, it feels weird to do now, to declare something on the stack. And I don't know where I'm going with that, but like maybe that dovetails into some of these other issues, that if these things were expressed in a different way, maybe it would be, maybe something would work out naturally that is not obvious to me right now. With the metaprogramming facilities, is it possible for the library writer to make a compile time check to see if the user called whatever newly required initializer was called? Yes, you could do that. Again, though, I mean, really determining that is equivalent to solving the halting problem, which you can't do, right? So what you could do is things that are easy to discern statically, like if they called the thing on the very next line or in the same basic block without any branching around it, right? Or whatever, stuff like that, you could tell pretty easily. But that does restrict, if you're going to error if you don't see that, then that does restrict the freedom of the programmer. But maybe that's fine. I mean, maybe there isn't maybe if you just decide to do that, there isn't so much a forward compatibility problem and we don't need constructors, maybe. The thing is that I haven't totally worked out a system of how do we organize it that libraries do metaprogram stuff, right? When your main program does metaprogram stuff, it's very easy for you to control that and make it happen, right? Then do you explicitly call out to the library's metaprogram stuff within yours? If that's the case, you might forget to do that, but then maybe the library can assert if something didn't happen, right? Like maybe that adds a value to your program and the library detects that you did that and compile time asserts if you didn't. I don't know. So there's a whole like convention there that hasn't been established. So maybe, again, maybe that would be a good alternative to constructors, for sure. I don't know. It depends on, you know, the good thing about constructors is they're very convenient to use. The bad thing is the invisible magic, right? So I've tried to minimize the invisible magic, but there is still a little bit. And yeah, I mean, we just have to decide what's the trade-off there. Has that megaton idea come to fruition, asks Dr. 2X or Dr. Twox. It has not yet, however, we're very close to being able to try it. The polymorphism cleanup that I did previously, that I streamed, was related to getting polymorphism ready so that I could build new features on top of it. And the megaton idea is one of those features. But I'm probably going to start with a slightly simpler one first. Why not make invoking the constructor extremely explicit, e.g. in Java you have equals new foo? Because by default that puts things on the heap, right? You could say equals stack foo or whatever. Maybe, but then again, the forward compatibility argument, like if that constructor didn't exist and then now it exists later, blah, blah, blah. I don't want to get into circular things. Like all the things that we've said so far in this discussion apply. Oh yeah, you could say alloca instead of new. Yeah, it's true. Can I tour my office? I don't know. It's hard to see things because it's dark. I don't know. Camera probably pointed down and you couldn't see anything anyway. Where are we looking at now? Would defining constructors be simpler if you just overloaded a global proc with a special name to take a pointer to your new struct and initialize it? I thought about that. So, you know, you could say that construct is kind of not exactly a reserved word, but would get called with the pointer to your thing. The problem is that that's pretty restrictive. You know, like you can't, like some of the cool stuff that we did about reusing polymorphic procedures would be hard to organize in that kind of a case. And I also just didn't like the idea of taking part of the namespace. Can the library user maybe set a variable as part of the import statement saying which API version they're using? Well, for sure. Like, we haven't gotten to the super formalization of library stuff yet, but when that happens, then yes, when you import a library, you'll say what version explicitly. You don't want things to magically break if somebody upgrades a library. That's no good. What would a modern version of BASIC look like? I don't know, man. What was that one thing in the demo that you said you were lazy and didn't do, but nobody cared so they wouldn't remember to ask about it in Q&A? I don't know if it's cheating to ask this, because I was thinking that somebody would ask about that feature by name. But the thing was, if you remember, you can tag procedures as symmetric, right? So that, for example, if you use them as operator overload for plus, that the arguments will swap if they type check in the other order. That should work with constructors, and I got lazy and didn't do it, right? But if we keep constructors, that'll work eventually. Am I still thinking about doing a namespacing feature? Yes. All right. About the scripts within the program, of course, you will be able to do that in some way, but not by interpreting them. Not by interpreting them with a heavy runtime. It would happen by like you include the library, or you include the compiler as a library, and then you use that library, right? So it won't be, interpretation of the language won't be built into the runtime because that's a bad idea, but yeah. So that, I think that's all the questions. Yeah, I don't know. If that's it, then I will go home and nap and someday work on new features. Yes, I am still taking emails at that address. Bye, everybody. Oh, write out the email. Okay. Everybody on YouTube can send me to here. It's not a mailing list, but I do read most emails that get sent there. I don't always answer because I don't always have time to answer, but if you have thoughts about this, if you have an alternative that will allow us to remove constructors and destructors from the language, but still be very robust, then send me those ideas here. See you guys.